Aim of the experiment: to study the reactions of hydrochloric acid with zinc metal, sodium carbonate, and sodium hydroxide. Theory: a dilute acid such as hydrochloric acid reacts with zinc metal to produce hydrogen gas and the corresponding metal salt of the acid. A dilute acid also reacts with metal carbonates and bicarbonates in a brisk effervescent reaction to form carbon dioxide gas along with the corresponding metal salt of the acid. Dilute acids also react with metal hydroxides, such as sodium hydroxide, in a neutralization reaction to produce the corresponding metal salt of the acid along with water. Materials required: zinc metal granules, dilute hydrochloric acid, sodium carbonate powder, sodium hydroxide solution, freshly prepared lime water, red and blue litmus papers, distilled water, 5 test tubes, a test tube stand, droppers or pipettes, spatula, a 1-hole rubber cork fitted with a delivery tube bent at right angles in 2 places. The rubber cork should fit in the mouth of the test tubes used for this experiment. Some wooden splints and a matchbox or lighter. Procedure: take a piece of zinc granule in a clean and dry test tube. Add about 10 milliliters of dilute hydrochloric acid to it. Record your observations. Now bring a strip of moistened blue and red litmus papers close to the mouth of the test tube. Record your observations. Next, bring a burning splint close to the mouth of the test tube. Record your observations. Take a spatula full of sodium carbonate powder in a clean and dry test tube. Add about 5 ml of dilute hydrochloric acid to it. Record your observations. Next, cover the mouth of the test tube using the rubber cork pre-fitted with the bent delivery tube. Immerse the other end of the tube into lime water and allow the liberated gas to bubble through it. Observe what happens. Take about 5 ml of dilute hydrochloric acid in a test tube and label it as A. Similarly, take 5 ml of 10% sodium hydroxide solution in another test tube and label it as B. Dip a blue litmus paper in test tube A containing dilute hydrochloric acid. Record your observation. Similarly, dip a red litmus paper in test tube B. Record your observation. Now, add dilute hydrochloric acid from test tube A dropwise to dilute sodium hydroxide contained in test tube B. Shake the mixture gently and drop a strip of red litmus paper into the reaction mixture. Record your observation. Keep on adding the acid from test tube A to the base in test tube B dropwise and mix the contents thoroughly after each addition. Carefully observe the color of the litmus paper in the tube during the mixing process. At a certain point, the addition of 1 final drop of the acid will cause the litmus paper in the tube to change back from blue to its original color red. At this point, dip a strip of blue litmus paper into the reaction mixture. Record your observation. Also touch the test tube and feel the temperature with your hands. Record your observation. Observations. The moment you add the dilute acid to the zinc metal in the test tube, an effervescent reaction occurs and gas bubbles are produced from the surface of the zinc metal. When a strip of blue and red litmus papers are brought close to the gas evolved, there is no change in color in either of the two litmus strips. The blue litmus remains blue, and so does the red litmus. If you bring a lighted splint close to the mouth of the test tube, the gas ignites with a characteristic pop sound. When acid is added to the carbonate in the test tube, a brisk effervescent reaction occurs and copious amounts of a gas is released. When the liberated gas is bubbled into clear lime water or calcium hydroxide solution, the lime water is seen to gradually turn cloudy or milky. When blue litmus is dipped into the test tube containing hydrochloric acid, it turns red. Similarly, red litmus paper also turns blue when dipped in the test tube containing sodium hydroxide. During the course of the reaction between the acid and the base, the red litmus paper placed inside the tube remains blue. At a certain point towards the end of the reaction, the addition of a final drop of the acid causes the blue color of the litmus to turn back into its original red color. At this point, when a blue litmus paper is dipped into the tube, it remains blue. When the tube is touched, it feels warm. Results and discussion. In this series of experiments that we have performed, we studied the chemical nature and behavior of acids when they react with metals and different kinds of bases. A dilute acid reacts with a reactive metal in accordance with the reactivity chart of metals covered in a previous video. The end result is usually the formation of the corresponding metal salt of the acid, along with the release of hydrogen gas. In this experiment, dilute hydrochloric acid reacts with zinc metal to form zinc chloride and hydrogen gas. The identity of the gas is confirmed by the ignition test, where a lighted splint causes the gas to ignite with a characteristic pop sound that is indicative of hydrogen gas. Dilute acids also react with carbonates and bicarbonate bases to form the corresponding salt of the acid, along with the release of carbon dioxide gas. This type of reaction proceeds with a characteristic brisk effervescence, wherein the reaction mixture bubbles vigorously, just like a bottle of carbonated drink when the cap is opened. The bubbles released are carbon dioxide gas. The identity of the gas is confirmed by passing it through a clear solution of calcium hydroxide, commonly known as lime water, which then turns cloudy or milky. This is because calcium hydroxide or lime water reacts with the carbon dioxide gas to form an insoluble precipitate of calcium carbonate, which causes the clear solution of lime water to turn cloudy white. In the experiment we've just performed, dilute hydrochloric acid reacts with sodium carbonate to form an aqueous solution of sodium chloride and carbon dioxide gas. A similar reaction occurs when dilute hydrochloric acid reacts with sodium bicarbonate. The reaction of an acid with either a carbonate or a bicarbonate base is said to achieve a neutralization point when the brisk effervescence ceases and bubbles are no longer produced. Dilute acids also react with hydroxide bases to form the corresponding salt of the acid. However, in this case, carbon dioxide gas is not produced, and there is no brisk effervescence as was seen in the case of an acid reacting with a carbonate or bicarbonate base. Hydrochloric acid causes blue litmus to turn red, and sodium hydroxide base causes red litmus to turn blue. When the two are mixed and allowed to react, they gradually begin to neutralize each other, causing them to lose their acidic and basic properties, respectively. At a certain point in the reaction, also known as neutralization endpoint, both reactants completely lose their acidic and basic properties to form a new product substance that is neutral in pH and is neither acidic or basic. The neutralization endpoint is visualized with the help of an external indicator such as litmus paper. In our experiment, the red litmus paper which was dropped into the reaction mixture turned blue and remained blue for as long as the concentration of the alkaline sodium hydroxide was higher in the reaction mixture. However, when the reaction reached neutralization, the blue color of the litmus abruptly changed back to its original red color. A blue litmus paper when dipped into the tube also remained blue without changing into red. In other words, the contents of the tube have become neither acidic nor basic, but rather neutral. The neutral product form in this case is sodium chloride in its aqueous form. A neutral solution is ascertained of its neutrality by the fact that it shows a negative litmus test. Blue litmus remains blue and red litmus remains red in such a solution.